So, what if the reason you're not healing isn't your diet, your supplements, or your labs, but it's actually your genes? Dr. Bob Miller is uncovering how genetic variants, when combined with modern toxins, explain why some of us stay sick no matter what we try. Today, we're talking genetic pathways, detox blocks, and the new science every wellness warrior needs to know. Welcome back to Let's Talk Wellness Now, the show where we uncover the root causes of chronic illness, exploring cutting edge regenerative medicine, and empower you to heal from the inside out. I'm Dr. Deb, your medical detective, and today, our guest, Dr. Bob Miller, is a true pioneer in functional genomics. He's board certified traditional naturopath and the founder of Nutrigenetic Research Institute, and he's the leading groundbreaking research on how genetic variants influence chronic illness, inflammation, and detoxification. His work has been recognized on international stages, uncovering links between genetic expression and conditions like Lyme disease, mast cell activation or MCAS, and mitochondrial dysfunction. I'm so excited to talk to Dr. Bob today. He is going to reveal some things that even I don't know about, so I'm excited to learn alongside of you guys. So, Dr. Bob, let's get started. Tell us a little bit about yourself and kind of how you got on this journey.
Well, that's interesting. I was sort of like a mid-career coming to the natural health field because in my early 30s, I found myself with a severe case of ulcerative colitis.
Mm.
And I was in the hospital for 21 days, probably within hours of death, bleeding to death. And they told me I've got one option, and that is cut out the colon and wear a bag. Didn't sound like a lot of fun.
Not an option I would want to choose.
So, the medical folks wasn't real happy with me, but I said, yeah, I'd like to explore some alternative things. Never thinking that I'd get into this field, and I just worked with some herbalists and things that I found absolutely fascinating. So that's how I got into this around 30 years ago, and haven't looked back since, and just having a blast as we now move into how our genetics impacts things. So
Yeah.
that's what we're gonna talk about today.
I'm excited to talk about this genetic thing. When you started over 30 years ago, what kind of patients and problems first inspired you to dig deeper into that root cause healing and kind of get into the genetic piece of it?
Sure. Well, as now I'm in a part of the country called Lancaster County, Pennsylvania, where there's a lot of Amish and Mennonite,
Mhm.
and they gravitate towards these things. So this is their first thing to do, and that doesn't work, then they'll go other route. Back then we just saw typical, a little tired, constipation, a little bit of fatigue, arthritis, those kind of things. Things have changed dramatically over the years as people are now getting more chronically sick. It's worse than it's ever been.
Yeah.
And what we're finding is the culprits primarily is mold exposure and Lyme disease. When people get those two together, it's an inflammatory cascade that nobody can seem to unravel. So that's where we spend a lot of our time. And we're also spending a lot of time looking at mental health like ADD, ADHD. And we give this year I'll be speaking at 3 autism conferences, and we can dig into that a little bit as to why we think we're seeing such a dramatic increase. And aside from autism, that used to be 1 out of 1,000, now is 1 out of 33 or 23. We're also seeing dramatic increases in ADD, ADHD. People are stressed out. And today I think we'll have the time to actually go through and show how environmental factors combined with genetics to cause that to happen. So we should have a fun visit here today, Dr. Deb.
This should be a fun visit. We can cover lots of topics. I am so excited. So, you founded Nutrigenetic Research Institute in 2015. What did you
Mhm.
hope to accomplish, and what kind of surprised you in your findings so far about that?
Well, let's back up at what, genetics is used for. Everybody's familiar with 23andMe and Ancestry that, tells you where your ancestors came from. Then you have your professional geneticists. I mean, these are people with the degree in genetics, and they'll look for, very odd sort of things that are prone to relate to a disease. So there are the disease-related genetics. Well, in functional, we don't look at either of those.
Mhm.
We look at, for example, how you're breaking down your fats and utilizing them, how you're recycling your glutathione, how you might be handling your iron. And none of those are disease causing on their own. But when they pile up on you and then combine that with environmental factors, that's when things start to go south on it. So that's what we're doing. We're looking at patterns. And
Mhm.
our first foray into this was we did studies on Lyme disease. So we looked at I think 50 people with Lyme disease. We looked at their genome and we found the patterns that were more evident in those with Lyme. Now, these genetics don't mean you get Lyme. It just means if you get Lyme, you react worse to it. So as you know, some people get Lyme, they go on a round of antibiotics and they're done.
Mhm.
Others have a little more struggle, and then others are struggling terribly for years. So there's an old adage of genetics loads the gun, environment pulls the trigger.
That is so true. And I think when we're talking about Lyme and mold and things like that, we forget sometimes that our genetics can predispose us to be more sensitive to those things. And if we have genetic pathways where we don't clear things properly, it's harder for us to get them out of the body. And then you add on that whole rain barrel effect that we've always used as a functional medicine term, right? If the barrel's half full, you're okay. If it's full and now it's spilling over, it's a bigger problem. Have you guys found too that some of these environmental things actually are changing the genetics of people or how they're processing their own genetics?
Mm. Well, let's go back to genetics 101. We'll go back a little bit further. So, what an interesting mechanism, what a miracle the body is. We
Mhm.
eat fats, carbohydrates, proteins, drink water, breathe air, expose to sunlight, and somehow everything gets made. I mean, when you just step back and think about that, it's like, that's pretty darn amazing that
Isn't it?
happens.
I always tell women, the fact that we get pregnant and we have healthy pregnancies and births is a miracle because if we had to try to control that, that wouldn't work so well.
Right. Well, that's another miracle. It's microscopic sperm and egg, human being 9 months later. It's like, wow. But
Yeah.
even inside of us, we are making our hair, our skin, our nails, our blood vessels, our ATP, our energy. It's all being created.
Hmm.
Well, that gets created by enzymes. So enzymes take one substance, combine it with something else, and make something new. Then another enzyme comes along and does the same thing. Your DNA is the instructions on how to make the enzymes. So when we are conceived, if it's a female, of course, it's the XX, the two chromosomes. Everybody's seen those, the genetics, that
Hmm.
twisted pair. So if it's a female, the father donated the X enzyme, and the mother has no choice but to give the X. So that's female. If the father donates the Y, you have a male that's in chromosome number 1. Then 2 through 23 is the rest of the instructions on how to make enzymes. So what can happen? We can get what are called SNPs, single nucleotide polymorphisms. And SNPs just mean that the instructions to make the enzymes not quite as good. So if one parent gives a SNP on the making of an enzyme, the enzyme is fine. It works. But general rule of thumb, it may only work at 70 to 80% of efficiency. Now, a good analogy is think of an 8-cylinder and a 6-cylinder car. If parents give you good information, that's like having an 8-cylinder car. If one parent gives you that SNP, it's like having a 6-cylinder car. Now, is a 6-cylinder car a fine car? Sure.
Yeah.
It'll get you from point A to point B, but it's just going to have the power of an 8-cylinder. Then if both parents give you a SNP on the same enzyme, it may be 30 to 40%, and that's like having a 4-cylinder car. Sits in the driveway, looks the same, puts gas in it, everything. But if you got a 4-cylinder car, probably not a good idea to go cross country pulling a trailer behind you up and down mountains.
This is true.
So we can get an 8-cylinder, 6-cylinder, or 4-cylinder enzyme. Now, if it's not under a lot of stress, if that 4-cylinder car is just taking you to the bank and the grocery store, it's just as good as an 8-cylinder car. But if you got to pull that trailer and there's a lot of stress on it, big mountains, it's going to struggle. Now, there's one other little caveat to this, and that is some genetic mutations are gain of function. They actually work faster. Now, we have enzymes that do all kinds of things. We have enzymes that make and recycle our antioxidants, but we also have enzymes that make inflammation. Now, that's a good thing because if we get a virus or bacteria, if you didn't make inflammation to kill it, well, we'd all die of infection.
Hmm.
So, we tend to think of free radicals as bad, antioxidants as good. They both play an important role. But interestingly, some of the major enzymes that make inflammation, they can be overactive. They can be turbocharged. And when they're stimulated by environmental toxins, they overreact. And therein lies the problem. When they overreact, we have a problem.
Yeah.
So if we have genes that overreact when stimulated, and then the enzymes that take care of inflammation are underactive, then you're going to be more inflamed. The majority of people that, come for functional medicine or naturopathic help are inflammation that they can't seem to get under control. And we will be, during this hour, we're going to look at some of the pathways that make that happen. So what we can do then, we can't change our genetics. When you're conceived, that's the hand you're dealt. When your life would be over, if someone would take some tissue and measure, it'd be exactly the same as conception. Does it change? But the enzyme's ability to do its job may be compromised because remember I said the enzyme takes a cofactor. So an enzyme takes substance A, cofactor makes substance B. Well, if that cofactor is not there, the enzyme's not going to work either. So you could have an 8-cylinder car, and if there's no gas in it, it's not going anywhere. So it's the strength of the enzyme, it's the cofactor to do the A to B conversion. And that's what we're going to get into. So many people say, well, where did these SNPs come from? Uh, Nobody knows for sure. Sometimes they're just called de novo when the sperm and egg go together. The instructions get mixed up a little bit. We do believe a lot of it came from a long time ago when we were almost wiped out by sexually transmitted diseases. And those
Mm.
STDs were altering the genes when the conception, in other words, when the sperm went into the egg, the STDs were interfering and causing the problem. So
That's
I often joke, if you want to blame somebody, blame your great 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 grandparents for being a bit promiscuous. So
yeah, for having a little too much fun, right?
exactly. So we don't know for sure, but there are some that, but most of the SNPs that we get inherit from our parents. So if you look at a child and you look at the SNPs, 99.9% of the time it came from one of the parents.
In identical twins, do they have the exact same identical
Hmm.
makeup?
Hmm. Yeah. Hmm.
But not in fraternal twins, correct?
No, no, those could be different. Yeah.
Those could be different because they have different sacs. They're not sharing that same genetic
Hmm.
makeup.
Yeah. So keep in mind, both your mother and your father have, the two strands.
Mhm,
And so you get one from one parent, one from another.
mhm,
So interesting situation. I had three boys, and we were looking at an enzyme related to breaking down oxalates. Now, the mother and father each had one SNP, and that's called
mhm,
heterozygous. Three boys, and they all come together. They're Amish boys. They're a lot of fun. And I looked at their genomes, and the one boy didn't have any SNPs at all,
hmm.
and one had one, and the other one had two.
Interesting.
So we don't quite know how these things get handed off, but with the parents each having one, you could have a child with none, one, or two. So the one, his ability to break down oxalates was just fine. The other was slightly impaired, and the other one was dramatically impaired. So you can have three children, and it all depends what the parents have. Now, if a parent has a homozygous or two copies, and the other parent has nothing, every child will have one.
Mhm.
Okay. If both parents are homozygous, that they both have two, every child will have two.
Two. Mhm.
Yes. So that's the way it works. But
Yeah.
but it's somewhat rare that both parents are homozygous on an enzyme, but it can happen.
Mhm. Do we think that infections today, like Lyme disease or mold exposure, things like that, if the parent, the woman primarily, I'm thinking, is pregnant and she actively has these infections, can those infections affect the genetics, kind of like a past sexual transmission did, where we thought back in the day?
Yeah, I mean, I'm not that much of a geneticist to answer that for sure, but my thought would be no, that at conception, the pattern's made.
Okay.
And then that's the hand you're dealt.
Yeah.
So I tell people we have good news and bad news. The good news is we can compensate for the weakness.
Hmm.
The bad news is we can compensate for the weakness.
Right. That is so very true.
Yeah, we can't, because I often get asked, so we'll do some things now and we'll check my genes again and they'll be better. It's like, nope.
Oh, mm-mm, mm-mm.
You got to play the hand you're dealt. So
That's right.
you can test your genetics. If you're looking at the same enzyme, you can test it every year. It's not going to change.
Yeah.
It's like the
But
blueprint.
it's good and bad, right? It's the one test you only have to do once in your lifetime compared
Yeah.
to
Now,
some of the other
unless,
tests
like
that we have to do all the time.
our test looks at called functional genomic analysis test, your genomic resource. We look at 220,000 SNPs,
Wow.
but
That's a lot of,
that's not all of them.
right. Hmm.
So maybe in the next year, we're going to come out with our third version of the chip. And then if someone wants to get those new things that weren't on it, they'd have to repeat.
Hmm.
But whatever we measured is going to stay the same.
That's a lot of SNPs to look at.
Keeps us busy.
Yeah.
But there's still SNPs that we'd like to have that we don't have. So
Hmm.
we started out with version one on our genetic test. Then we worked to version two, and we're already compiling a list of what version three would look like.
Hmm.
So if somebody has our version two, and we're saying, you know what, it'd be nice if we could see these, well, then you repeat, but
Hmm.
it won't change what you already know. So
Got it. Got it. So, when you started out and you started looking at the research of Lyme disease and chronic infections, which detox pathways are most important for people who struggle with those conditions?
okay. You know what might make sense as we do a screen share, I'll actually show you the
Yeah,
pathway. That makes sense?
absolutely.
All right. So let's see if let me just press the share
Yep, you should just be able to press share.
and number two. Okay. We seeing the screen there?
Yep.
Okay. So this is a map that we made. And by the way, this is not all inclusive of all the things we look at, but we believe this is
Hmm.
a core issue. So where we're going to start here, there's something called the microglia. And the microglia are glial cells that are in the brain and the central nervous system. And they're very interesting little creatures because most of the time, and this is just a drawing of what they sort of look like, most of the time they're in what's called the M2 anti-inflammatory mode. What that means, these little guys pick up dirt, debris, recycle them, turns on an enzyme called interleukin 10 that's anti-inflammatory, and just kind of does general housekeeping. However, when a trigger comes along, it's the same glial cell, but it moves over to a very pro-inflammatory enzyme, a pro-inflammatory glial cell. And it triggers these three enzymes, actually these four, that are pro-inflammatory. Tumor necrosis factor alpha, interleukin 6, NF-kappa B, INOS. Now, these create inflammation. So you might think, well, why is that good? Well, if you have some foreign invader, virus, bacteria coming in, parasite, if you didn't have these guys coming to the rescue, you would just die of infection.
Mm-hmm.
So these guys are your friend unless they're your worst enemy. Because TNFA, and we'll show you when we actually do a demo account, TNFA can be overactive. So in other words, it over responds. Interleukin 6 can be overactive. NF-kappa B can be overactive. The INOS, and I'll explain each of these as we go through a demo, can be overactive. Now, what that means is you're very good at killing virus and bacteria, but this is where autoimmune disease comes in and just inflammatory conditions. Now, this is just speculation, but we think what happened is, as you know, thousands of years ago, we didn't have refrigeration, we didn't have sewer, we didn't have pure water, we didn't have antibiotics. So if you made it to 40, you were an old timer because everybody was dying of infection. So what we believe happened is by what's called natural selection, having these overactive 1,000 years ago was to your advantage.
Mm.
But now we have pure water, we have refrigeration, we have sewers, we have antibiotics, but now we have environmental factors that are stimulating them. Now it's to our disadvantage. And we'll talk about that a little bit as it relates to the hemochromatosis genes and maybe the G6PD.
Yep.
Now, why are we becoming so inflamed? Let's look at the triggers. Now, one of my favorite expressions is, I was born all the way back in 1954, and it was a different world back then.
Mm-hmm.
These are some of the triggers. But we'll get into these, but high fructose corn syrup and the high-fat diet. High fructose corn syrup only came about in 1968. So now we're being exposed to high fructose corn syrup. Then we didn't have these viruses like COVID.
Yeah.
No, there's now pretty strong evidence that COVID was actually, made as a gain of function.
Mm-hmm.
It's debated, and I'm not taking an opinion on it, but there's some people that believe Lyme disease was also a part of experimentation.
Yeah.
Then we have molds, and it appears as though mold is getting stronger. You know, 20 years ago when I was seeing folks, mold wasn't on the radar.
Mm-hmm.
I would say 7 out of the 10 folks we speak to today have mold problems.
Yeah.
Now, we
Yeah.
don't
20
know.
years ago, we talked more about mold allergy being an issue versus mold toxicity being an issue.
Right. So I know some folks are, speculating what's happening, but one of the theories out there is that EMF is strengthening mold.
Mm-hmm.
I don't know if you ever heard that theory, and
I have.
I'm not claiming it's true, but it's an interesting
Mm-hmm.
theory. Then even, your black mold from water damaged buildings. Then our air pollution is getting worse. We're getting more toxic metals. If we
Mm-hmm.
have we're going to look back someday and say, what were we thinking smearing aluminum into our armpits? What were we doing putting mercury in our teeth?
Mm-hmm.
Uh, then, glyphosate. When I was a kid, there was no glyphosate. So all of these herbicides and pesticides,
Mm-hmm.
polychlorinated biphenyls, and then EMF. So we love our cell phones, and I think unless you are in the middle of the desert or down in a cave, you're being exposed to EMF somewhere.
Mm-hmm.
So, we have our cell phones with us. We have Wi-Fi, the towers are everywhere. And we don't know long term, but we may find that this creates some inflammation. And I don't know if you get any folks, but do you have any folks that are they're EMF sensitive?
Oh, yeah. We have a whole bunch of them. Mm-hmm.
Yeah. And then if you have any TBIs.
Yeah.
So plenty of things here that will stimulate into the microglia M1. Now, you could say, well, we're all pretty much exposed to the same thing. Why do some people get hit harder than others? So here's where we're going to start. There's an enzyme called NRF2, NRF2. And NRF2 is the enzyme that senses when there's inflammation and turns on hundreds of anti-inflammatory enzymes. We'll show when we do the demo, you can have genetic weakness on NRF2. And NRF2 inhibits and slows down microglia M1, supports M2. Now, if it's not complicated enough, there's an enzyme called KEAP1. And KEAP1 inhibits NRF2. And you can actually have gain of function on KEAP1 that makes KEAP1 stronger. So a lot of the people who land on my doorstep, both parents gave a mutation on KEAP1, making it overactive.
Mm.
Suppressing NRF2, NRF2 might be weak. So nobody's putting the brakes on M1. And by the same token, NRF2 supports M2. Then there's a process called mTOR and autophagy. mTOR stands for mammalian target of rapamycin, the growth of new cells, and then autophagy, taking our dead cells and recycling them. We need a balance between the two of them. If we didn't have mTOR, the sperm and the egg would never become the baby never become the adult, we wouldn't make new cells. But our cells are constantly, the old cells dying off. Autophagy is where we take that debris from the cell and recycle it, just like a farmer plows the crop under at the end of the year. The dead plant then becomes the fuel for the spring. Your dead cell becomes the fuel for the spring, and that's autophagy. So we're going to look back someday and say, what were we thinking?
Mm-hmm.
We give our animals growth hormones so they get fatter faster. Oh my. So we consume those animals and mTOR runs faster. Now, for anybody who's maybe above 40, 45 years old, think back when you were 12 and what did girls look like? They were primarily flat-chested little girls.
Mm-hmm.
Now they look like 16-year-olds because environmentally we're jacking up mTOR. So mTOR stimulates microglia M1, suppresses microglia M2. Probably 80% of the folks we visit with, this is the part of the problem. NRF2 is weak, mTOR is strong, environmental factors come along, and this guy gets carried away.
Mm-hmm.
He doesn't do that burst and move back, stays here. We're calling that how environmental factors create a locked-in pro-inflammatory and neurotoxic phenotype. In other words, once it starts, it just keeps feeding upon itself. All right, so what happens now when microglia is overactive? It triggers these three enzymes, TNF-A, NF-kappa B, and interleukin-6. Each one of these can have genetics that make them run stronger. Then it stimulates an enzyme called NLRP3, which makes what are called inflammasomes. Now, guess what inflammasomes can be? Your best friend or your worst enemy. Because they will, if you've got, again, a virus or bacteria, or possibly even some bad cells in the body, they will zap them. Well, that's good, unless it's overactive. And then what it does through interleukin-1 beta makes excess glutamate, anxiety, gut inflammation, OCD, ADD, autism. And, glutamate, we'll talk about that a little bit, but glutamate makes you intelligent, highly motivated, go-getter, but can also be excitatory. And then look what it does. Let's see, do I have the drawing tool here? Yes, I do. Okay. So it comes down through here, makes the glutamate, comes back up through here, through the ADORA 2A enzyme. Then we got a feedback loop that feeds upon itself.
Hmm.
Then through interleukin 18, we make histamine and mast cells. And then through histamine receptor site number 1, we come back and spin it. And now you've just got this spinning feedback loop. So the glutamate will make you anxious. The histamine will give you allergies and make you anxious. and you're allergic to everything and you're feeling horrible. Now, it doesn't end there, Dr. Deb. It then goes on to make something called gasdermins that creates pyroptosis, where it actually starts punching a hole in the cell membrane. And you're only going to be as healthy as your cells are. Just a little background. We're made up of trillions of cells, and each one of them has what's called a lipid bilayer, made from lipids, which comes from fats. And you're only going to be as healthy as those membranes are. So that's why we coined an interesting phrase, cellular CPR. Construct the cell, protect the cell, and restore the cell membrane. And we believe that's going to be revolutionary in the functional medicine world.
Hmm.
So it's not hard to figure out that if you start punching holes in the cell membrane, that's not a good thing. Okay.
Right.
Now, there's an interesting molecule called NAD, nicotide adenosine dinucleotide. And anybody who's in the, listening to the health podcasts and things, they're uh, they're learning about NAD. And I'm going to show you a chart later, all the good things that NAD does, but for the most part, it helps what's called sirtuins. And sirtuins are quite interesting. If anybody's looking at longevity, the sirtuins is where they're looking at. Because sirtuins turn on good things, turn off bad things. And I'll show some charts on that later. So for right here, this sirtuin uses NAD to slow down NF-kappa B. SIRT2 uses NAD to slow down NLRP3. So if we've got genetic weakness on these, or we don't have enough NAD, we don't hold this pathway back. Make sense?
Yeah, makes perfect sense.
Now, I'll show this a little bit later. So people are like, oh, well, I'm going to start taking some NAD.
Right.
And there's functional doctors who give NAD intravenous.
Hmm.
It was just this morning I was talking to a woman who said, oh my gosh, I went and got intravenous NAD and it took me a month to recover from that.
Mm.
What happens is, and I'll show this in a little more detail, there's an enzyme called CD38 that's stimulated by NF-kappa B, and it takes NAD to make intracellular calcium that stimulates NLRP3 and actually makes things worse. So if we have this guy upregulated, and I'll show a chart what does that, taking NAD will make you worse. Again,
Mm.
when I go into the software, I'll show you that whole pathway. So I would encourage people, just don't go out and start taking massive amounts of NAD. Stick your toe in the water, see how you do. Because everything you've heard about how good it is true, unless this guy says, oh, thank you very much, let me make more inflammation. Now, this might be part of our innate immune system that if we have some pathogen that's going to kill us, by golly, we want that to happen.
Hmm.
But if this is happening by environmental factors, then it's detrimental. So the immune system that protected us 1,000 years ago now might be turning on us because of the environmental factors that we showed earlier. All right. Then there's an enzyme called PARP that's NAD dependent, and that actually repairs strain breaks in your DNA. Now, the next thing that happens is there's an enzyme called NADPH oxidase that gets stimulated, and something called INOS. Now, I'm sure most people know about nitric oxide. It's a gas that dilates your blood vessels. That's why sometimes they'll even give people drugs, nitroglycerin, to boost their nitric oxide. That's why people are doing beetroots and other things to boost their
Mm.
nitric oxide. But there's a NOS3 enzyme that makes the nitric oxide that's good for blood flow. But there's an INOS that makes nitric oxide to kill pathogens. But it might be the third or fourth time I've said this. That's a good thing unless it isn't. So if it's killing some pathogen, great. If it's just misfiring, it combines with superoxide that's made by this enzyme and makes something called peroxynitrite, which is one nasty free radical that chews you up and spits you out.
Mm.
So the NOx enzyme, NADPH oxidase, uses NADPH to make this free radical called superoxide. If we have time, we'll get into it. NADPH is what your body needs to recycle your antioxidants. So I coined the phrase the NADPH steal, where the NOx enzyme takes this very important NADPH and rather than being useful, makes superoxide. Now, again, is that fine if you got some bacteria to kill? Of course. But if it's just chronically running, it's just making all this chronic inflammation. Then it makes something called hydrogen peroxide. And we need to clear hydrogen peroxide by three enzymes: catalase, thyroredoxin, and glutathione peroxidase. If we have genetic issues on here or we don't have the cofactors, there's something called the Fenton reaction discovered in 1895 by Dr. Fenton, where hydrogen peroxide combines with iron to make what are called hydroxyl radicals. And guess what they do? They create lipid peroxides that damages your cell membranes. Now, again, the body is pretty darn amazing. We have glutathione, and here's where your body's taking glutathione and recycling it. But look who's needed to recycle it, NADPH. So if this guy up here is chewing it up, we don't recycle our glutathione. And then an enzyme called glutathione peroxidase 4 takes this damaged lipid and repairs it. So here we've got this protecting. We want to protect it by not having this happen. But then we also need this guy to do the restoration. So there's a lot that can go wrong in here, Dr. Deb.
There's a lot that could go wrong. And I can imagine some of my listeners are thinking that lipid peroxidase, is that the same thing as what they're thinking of when we talk about lipids and cholesterol? Is that the same process that's happening there?
Well, no. The lipids can be used to make cholesterol, but here we're talking about where they're going to build the cell membrane and they're being destroyed.
Hmm.
If anybody would like to see a visual representation of this, just go on YouTube and type in ferroptosis animation. Cool little video. It's about 3 minutes long. And it shows the lipids coming over, being oxidized, and how GPX4 fixes them. So YouTube, ferroptosis animation, cute little video. It really shows vividly what we're talking about here. Now,
And, and so this is very common too. Like a lot of people do hydrogen peroxide IVs.
right.
And so if somebody doesn't know their genetics, they could have a problem with doing those, just like they could doing the NADH IVs, correct?
Sure. Yeah,
Yeah.
yeah, yeah. So I've talked to so many, of course, the hydrogen peroxide kills pathogens. I mean, that's what it
Hmm.
does. So, but I've spoken to so many people that said, I had one client that said they've never been the same after having one hydrogen peroxide infusion.
Interesting.
Yeah. So it can be, I see why people use it because it will kill the
Hmm.
pathogens. But on the other hand, and now's a good time to speak about, I don't have it on here, but there's an enzyme called the HFE gene, and that is what causes you to absorb iron. And there's mutations in it that cause something called hemochromatosis, where you overabsorb iron.
Hmm.
Now, true hemochromatosis is when both parents give you a mutation. But there's now growing evidence even a heterozygous can cause a little bit more iron absorption, not to the hemochromatosis point, but overabsorption. So if you overabsorb iron and you have too much hydrogen peroxide that's not cleared, all kinds of inflammation.
Hmm.
Now, what happens is sometimes this inflammation will damage the red blood cells, and some well-meaning doctor says, "Oh, you need some iron," and they take iron and it makes it worse.
Hmm.
So can't tell you how many people I've said you've got the overabsorption of iron, and they say, "Well, that can't be right because I'm low in iron." Well, that could be because it's being chewed up here.
Sure.
So the solution isn't take more iron. The solution is clear the hydrogen peroxide, turn it into water and oxygen. GPX1 and TXN turn it into to water. The catalase turns it into water and oxygen.
Mm. Now, I see a lot of my clients who have mutations or SNPs on that GPX gene, on that glutathione gene, and they really struggle to clear a lot of their toxins.
Sure. Yeah, absolutely.
Yeah.
Well, GPX4 is what repairs, but you can see GPX1 is what uses glutathione. to
Hmm.
turn hydrogen peroxide. So, but it all depends upon having enough glutathione.
Yeah.
Well, guess who controls making of glutathione?
Hmm.
Nerve 2. So if you have a keep one weakness, or strength to two, I'm sorry, keep one is too strong, nerve 2 is too weak, you don't make glutathione. So when a lot of people do that, it's like, well, I'm going to take glutathione.
Right.
And some do great and some do poorly. Because, and I'll show this on one of the other charts, you can see here that the glutathione has to be recycled.
Hmm.
And if we don't recycle it, it actually turns into superoxide free radical. So NADPH are the cofactors for taking the oxidized. Here's oxidized glutathione, here's reduced. So this is the good glutathione. After it does its job, you can see it becomes oxidized. We need to recycle it. Well, if we have weakness on the enzyme that does that, or weakness in nerve 2, or not enough NADPH, the oxidized glutathione never gets recycled. So I've talked to a lot of people and said, oh, glutathione made me so sick. It's like, well,
Yeah.
you need it, but you need to recycle it.
Mm. Can you speak for just a brief moment too about MTHFR? That is a very popular gene. It's all over social media as the major gene. But can you speak to a little bit about that and how that fits into this whole process of things? Because it is just such a small piece in
Mm,
understanding genetics.
yeah, to be honest, it drives me nuts.
Me too.
All right. So, there are people on social media. I won't say what I think. I'll be kind. But but and they might mean well, but they talk about if you have MTHFR and COMT and PEMT, that's oh my goodness, that's horrible, and we'll fix that for
Hmm.
you and you'll be fine.
Yeah.
Um, it just irritates me to no end. And it really could get anybody who's doing this legitimately in trouble. I mean, I'm afraid someday, there might be some cracking down on this kind of nonsense.
Hmm.
Now, to answer your question about MTHFR, I mean, it really is. But I'll tell you what, why don't we hold that thought until I go to another map and I can actually show
Okay.
you. Yeah. But the cliff notes is the MTHFR puts a methyl group on your folate, which is needed, but it has gotten way, way, way too much attention.
Hmm.
And people learn they have MTHFR and they start taking a multivitamin with methylfolate. Then they take a B vitamin with methylfolate and they're pushing it too hard.
Yeah.
So I can't tell you how many people I've helped by saying, stop it.
Yeah. Take less of it.
Take less of it. Yeah. Take
Hmm.
less of it. Yeah. Yeah. If somebody'd say rank the enzymes of their level of importance, uh, MTHFR might be 40 or 50 on a scale of 100.
Hmm.
Uh, keep one, nerve 2, big deals.
Big deals. Hmm.
NQO1 that I didn't even talk about yet. NQO1 um, takes your NAD goes into NADH to make electrons for the electron transport chain. You need NQO1 to bring that back. If that's not working, and I'll show you on the NAD map how disastrous that can be. Now, the next piece is here, and I think, if you talk to any school teachers and say, if you've taught for more than 10 years, how are the kids today? Every one of them says more ADD,
Yeah.
ADHD, more autism. Just look at human beings. We've never been so agitated.
Hmm.
Everybody, and it might be a social media thing, but people take a position on something, and if anybody doesn't share that position, they view them as the enemy. And it's,
Hmm.
it's kind of scary what's happening to us. So we can't agree to disagree anymore. We see anybody who has a differing opinion as the enemy. And there's people that didn't have Christmas dinners together because they had political
Yeah.
differences. Like,
Hmm.
seriously, can't you put your political differences aside to have Christmas together?
Right. I
But to
agree.
become that, no matter what your position is, and I'm not saying anyone's right or wrong. I'm just saying, in the old days, they used to say that the Republicans and Democrats in Congress would argue policy and then go have dinner together.
Hmm.
And now everybody's all up in arms, angry. Okay.
Yeah.
So there's likely multiple reasons for that, but let me show you one of them. That, to what degree this is very important, we don't know, but I think we're beginning to believe this is very important. So there's a neurotransmitter called GABA. And
Mhm.
GABA is the don't worry, relax, be happy, chill. Okay.
And
Now,
nobody has enough of that anymore.
well, yeah, you'll be surprised what I'm going to show you. So let me see if I can find let me see if I can find the right slide here. Let me look for it here. So there's something called a GABA receptor site. And here you can see this is a neuron, and this is where the neuron normally is excitatory. However, there's normally low chloride in the neuron.
Hmm.
So GABA itself is neither relaxing or excitatory. All GABA does, it opens up what's called a chloride channel. And then chloride, which has a negative charge, will flow into the neuron. Follow me there?
Yep.
And as it does, it changes this from a positive charge to a negative charge, and it's relaxing and inhibitory.
Hmm.
Now, on the other hand, there's enzymes called NKCC1 that will push chloride in, and KCC2 that will bring chloride out. And then there's a sodium channel, and sodium has a positive charge, and glutamate will push that in. So as long as this is happening, and GABA says receptor sites open, chloride goes in, chill. However, if NKCC1 pushes extra chloride in, KCC2 doesn't pull it out, and GABA hits the receptor site, the GABA comes flowing out, sodium comes in, and now it's excitatory.
Hmm.
So GABA didn't change. GABA just opened the receptor site. That's all it does.
Yeah.
But it's the chloride balance that's going to determine whether this is relaxing or not. Now, these are the things that go along with when they lose that KCC2 or gain NKCC1. Pain and sensitivity, burning electrical neuropathic pain, normal touch hurts, sound and light sensitivity, tinnitus can flare, headaches and migraines, seizure tendency, body jolts, spasticity, cramps, stiffness, startle reflex, trouble falling asleep, non-restorative sleep, anxiety, stress, reactivity. That's what we have now. Hyperarousal, panic-like surges, irritability, racing thoughts, brain fog, slowed processing, working memory slip-ups, mental fatigue, episodes of racing hearts, sweaty palms, guts on edge.
Hmm.
Those are all the things that happen when this GABA switch occurs. Now, here's what happens, and this is what I'm going to be presenting at an autism conference. When you have a newborn, they need that NKCC dominant to develop. By early childhood, early adulthood, we should move over to the KCC dominant. That's the taking the chloride out. Nice looking 25-year-old boys functioning very
Mhm.
well. However, when we get microglia M1 upregulated because of environmental toxins, processed foods, Tylenol, aluminum, they stay in NKCC1 dominant. And there's ADD, ADHD, autism, the whole spectrum, because they've not moved over to the
Mhm.
they've not moved over to the KCC2. And again, this is caused by environmental factors stimulating the microglia. And then interleukin 1 or interleukin 18 weakens KCC2. Interleukin 1 beta strengthens NKCC1. High chloride, we open up the chloride channel and we become excitatory.
Hmm.
So I think when the pediatricians get a hold of this, they're going to be very excited to know that this
Yeah.
could be why we're seeing such a rise, and not just autism, but ADD, ADHD, anxiety, the whole shit
The
match.
whole thing.
Yeah. So, and you can see NF-kappa B stimulates that. These stimulate it, and I think that's why everyone's getting so anxious. Okay.
Hmm.
Now, it's a little bit more to it. We'll get into this when we look at some of the maps, but the uh, the glutamate, which is excitatory, will stimulate the NMDA receptor, make more glutamate, and glutamate will inhibit KCC2. And then we also need an astrocyte to take both ammonia and glutamate and turn them back into glutamine. And I'm going to talk to you a little bit about arachidonic acid. And if we have too much arachidonic acid or TNFA is upregulated, that doesn't happen. Ammonia goes up, and there may be multiple reasons for this, but this is a reason why some of the autistic kids do flapping
Mm.
because they're not clearing their ammonia. And you can tell if somebody has high ammonia by they get that old person smell, you know,
Yeah.
because the
Yep.
urea cycle is not taking out the ammonia. Now, last pathway here, there's growing interest in mast cell activation. So back here, we talked about peroxynitrite, and that will stimulate mast cells, and those are white blood cells that are your best friend unless they're your worst enemy. Then it'll make histamine, and there's enzymes called histidine decarboxylase that'll make more. I'm sure everybody's heard of DAO, the enzyme that degrades histamine.
Yep.
We can have genetic weakness, we don't make that. There's an enzyme called histamine unmethyltransferase that that breaks down the histamine. Then if we don't do that, it'll get stuck in the histamine receptor site, and then it'll make something called renin, which will cause angiotensinogen to turn into angiotensin 1. That turns into angiotensin 2, and that's where people make aldosterone, where they'll get the swollen ankles and high blood pressure.
Mm.
But interestingly, there's an enzyme called ACE2 that takes this guy and turns it into angiotensin 1-7, which is anti-inflammatory and also inhibits TNFA. Now, you can have weakness on ACE2, but in anybody saying that sounds familiar, that's where COVID comes in using ACE2. And now we just found there's literature that if you get COVID long enough, it can actually make ACE2 not be able to work as well.
Hmm.
So look what it does. It comes down here, stimulates the NADPH oxidase, more superoxide, more peroxynitrite, and we're on a cycle here. We've actually named this the home cycle hypothesis, a proposed feed-forward loop that just keeps feeding on itself. All being caused by primarily the environmental factors, but hitting those who have genetic weakness the hardest. That's why two
Mm-hmm.
people can live in a moldy house. One person is sick as can be, and the other person says, well, you must be imagining things because I don't feel anything.
Yeah. Same thing with long haul, right?
Sure.
Two people can both get sick. One gets sick and never seems to recover, and somebody else gets sick and they have absolutely no problems with it at all.
Sure. Well, think about it. If you get COVID and ACE2 is weak and some of this other stuff is going on, this thing just starts feeding upon itself.
Hmm. Keep creating more inflammation, more complications, nothing's calming down.
Yeah. Now, you asked about MTHFR. So this is the software called functional genomic analysis. This is a demo report we have. So let's talk a little bit about MTHFR. So we actually have a map called a methylation map. Now, what happens is when you do your saliva test, you spit, you put some saliva in a collection kit, goes to a lab, takes out the DNA data, sends it to the computer, and now you can actually see it visually. Okay. So it's going to take a second for this data to load up. And each of these circles, each of these ovals is an enzyme. And the data gets loaded up to see where it is. So until it gets loaded up here, I didn't preload this. There it goes. So the primary thing about methylation is there's a nasty substance called homocysteine that if it's too high, it can really be detrimental.
Hmm.
The body takes methylfolate and combines with methyl B12 to bring this back up to methionine. And then through the MAT genes, we make SAMe, acetyl methionine, which is involved in so many processes. Then after it does its thing, it turns back into homocysteine, and this thing needs to keep spinning around. That's why it's a good idea to keep homocysteine at, do you have a number that you like? 7, 8? What do you like for a number?
Yeah, I like mine below 7.
Yeah. So if the homocysteine goes too high, it causes all kinds of problems.
Hmm.
So here's where you ask about the MTHFR. So here you can see on this individual, I click on MTHFR and you can see it comes up here. Here's the C677. And you can see here where it says variants. I'll draw in case somebody's having a hard time seeing that. So you can see there's nothing in there. That means there's no genetic mutations. If one parent would have given a mutation, there'd be a 1. If both parents did, there'd be a 2. Now, here's why. Yes, methylation is important. I'm not saying it isn't important. But look at this MTHFR C677. In my software, only 42.5% of the population does not have a mutation.
Hmm.
44.7% have 1, 12.9 have 2. So this isn't some rare, oh my God, I'm going to die kind of thing. Yeah.
Right,
So, and then what happens is that, and again, I'm not dismissing methylation. We could do a whole show on methylation. I
right.
get it. But I think that what people are doing is they're learning about MTHFR, they get it measured, they panic, and
Hmm.
they start taking massive amounts of methylfolate, which many times is to their detriment.
Hmm.
Yeah.
Well, isn't it true too with MTHFR? Like you have to also look at MTR, MTRR, and the more we stack up of those, the more complicated then MTHFR can be. It's not as simple as just saying MTHFR 677 versus 1298. It's more complex than that, kind of like what you've already shown with some of the
Right.
other things. There's more to it than just that one little sliver.
Oh, sure. Well, let's take a look. So remember I said there's a cofactor. One of the cofactors is called FAD. Okay.
Hmm.
Just a Bob Miller observation, that's all. But when people have trouble with their riboflavin and they don't have enough FAD, they're doing much worse than people who have just a C677.
Hmm.
So right here, you could have perfect C677. And if you don't have the cofactor, it's not going to work. Okay.
Hmm.
And as you said, there's an MTR enzyme that takes methylfolate and methyl B12 to spin it around. So here on this individual, here's your B vitamins, or I'm sorry, your B12s. There's an enzyme called TCN1 that takes it from the stomach into the blood. Then there's other enzymes that take it from the blood into the tissue. And if you're having trouble here, well, then you're not going to have this working. So even if you don't have MTHFR and you have MTR like this, no, I'm sorry, this person doesn't, but they
Hmm.
have the MTRR and then they don't have enough B12, this isn't going to work aside
Hmm.
from that. And then there's a middle pathway. And then there's enzymes called the MAT1. They take the methionine to the same. If that's not working, we get stuck in methionine. So it's not just an MTHFR. And then one of the things that people forget about is through the CBS enzymes and CTH, we make cysteine, which is needed to make glutathione,
Hmm.
the master antioxidant. So it really is that I call it the 3D chess game played underwater.
It really is. I mean, I see people who have CBS, COMT, glutathione, MTHFR genes, and some of them function just fine. Like they have,
Sure.
like I look at this person and I'm like, oh my gosh, I don't know how they're functioning because they're double mutated on so many pathways, but yet they don't have a lot of symptoms. They don't have a
Mm,
lot of complications. Somehow their body has figured out a way to adapt to what it has so it can stay alive and it can function at a high functioning level.
yeah, and they may be, eating right,
Yeah.
staying out of a moldy house,
Hmm.
reducing stress. So it's diet, it's stress, it's genetics, environmental factors.
Hmm.
So yeah, we can't just say somebody's going to be good or somebody's going to be bad. I know that some people get scared. Oh, I got all these. It's like, well, are you
Yes.
living in a moldy house? You know,
Right.
and if you live in a moldy house and your glucuronidation pathway doesn't do well, or if you're, a smoker or you're constantly eating junk food, I mean, all of those
Hmm.
things come together. Although, what we focus on genetics, we're well aware that this is just a piece of it. You could have identical twins, genetically. And if one is exposed to mold and smokes and drinks and stressed
Hmm.
out, they're going to be a whole lot sicker than their sibling.
Yeah.
Yeah.
Yeah. It's that
So,
concept of taking twins and one gets raised with one family and one gets raised with another family, and they don't have the same
hmm,
problems that
yeah,
each other have, you know? It's very unique situation. We don't think about that enough.
right. So again, genetics loads the gun, environment pulls the trigger.
Hmm.
So if you've got a loaded gun, but you don't have the triggers, you're okay.
Yeah.
Yeah. So remember I said I was going to talk about NAD.
Hmm.
So here's NAD, and what it does, it turns into NADH. And what NADH does, it comes down this pathway, what's called the electron transport chain. And that makes your ATP, that's your energy. So if this wasn't working, we wouldn't be alive because we wouldn't have energy.
Hmm.
So it donates an electron, that's why it's called electron transport chain. So we need NAD to make this, to make the energy. But remember I said that NQO1, this would probably be like on my top 10 list of genetic
Hmm.
mutations, much more important than MTHFR. This one takes NADH back to NAD. If we're stuck over here, we're low in this NAD plus, but what happens is NQO1 also provides CoQ10. And CoQ10 is what's needed for the electron transport chain to flow. So if we get too many electrons up here and they don't turn them into energy, they make a nasty free radical called superoxide. Okay.
Hmm.
Now, NAD plus also makes NADPH, and that is needed. Remember, I said we need to recycle our antioxidants. So if we have a problem with FAD from riboflavin and we don't have enough NADPH, glutathione's not getting recycled and you're going to be inflamed. And you take glutathione, you'll feel worse. There's another enzyme called thyroredoxin. Same thing, needs NADPH and FAD. And same way with your nitric oxide. There's an enzyme called NOS3 that makes the nitric oxide that dilates your blood vessels. And if we don't have enough NADPH or FAD, you're going to make superoxide rather than nitric oxide.
Hmm.
Now, remember I said earlier, the NOx enzyme takes NADPH to make superoxide. So if this guy's upregulated, we're not going to have our NADPH and we're going to make inflammation. Now, I'm going to show you the sirtuins a little bit later, but the sirtuins do a lot of important jobs. SIRT3 helps an enzyme called superoxide dismutase neutralize the superoxide. The uh, the SIRT2 stops the guy who makes the gas Germans that damage the cell membranes. There's an enzyme called PARP that does repair. All of those are NAD dependent. So you would think, well, the more NAD I get, the better off I am.
Hmm.
But remember, I said earlier, there's an enzyme called CD38. And if we're exposed to mycotoxins, Lyme, aluminum, too much EMF, high fructose corn syrup, lead, mercury, glyphosate, cigarette smoke, diesel exhaust, dioxins, herbicides, it'll stimulate this CD38. Hang on to your hat here, Dr. Deb. Takes 100 molecules of NAD to make one molecule of cyclic ADP ribose. And that's going to stimulate the NLRP3. And if this starting to sound like Chinese now, that's this guy right here that makes all that inflammation. So that's where if you take NAD while this is upregulated, you can make yourself worse.
Hmm.
So we do a test called US Biotech NAD, very valuable. It'll measure the NAD, NADPH, NADH, and if this guy's high and this guy's low, we may have to first work on getting this over. And look at there's only one thing that'll do that, Paudiarco,
Hmm.
called beta-lachome, that will help the NQO1 bring this back. So sometimes what we have to do is we have to pull this guy over, calm this guy down, only then start putting a little bit of NAD in. Now, the one of the pathways that we're really, really excited about. This is one of the new ones we're looking at. And I think this is going to be a real game changer. Inside the cell membrane, there's something called arachidonic acid. And it helps, it's useful, helps the skin, helps, give strength to the cell membrane. But there's an enzyme called PLA2. And PLA2, when stimulated, will pull arachidonic acid out of the cell membrane. And people are going to resonate with this. It stimulates the COX enzymes, COX-1 and COX-2, that makes prostaglandins. Now they're like, well, I've never heard of that. But everybody knows Tylenol, aspirin, Excedrin, ibuprofen, they inhibit these enzymes. And that's why they're pain relieving. They might kill your liver and kidneys, but they're pain relieving.
Mm-hmm.
I've seen a couple people now that have kidney failure because of taking, for years, taking NSAIDs. So that's where aspirin and all these guys work. They calm this guy down.
Mm-hmm.
But now we believe a better solution is, how about if we pull less arachidonic acid out of the cell membrane? So what does that? Look at our players. NF-kappa B, interleukin-6, tumor necrosis factor, same ones. They will stimulate this guy to pull arachidonic acid out of the cell membrane. Now, what's interesting is what else does this? There's something called an NMDA receptor that will, again, stimulate that intracellular calcium. And there's genes called GRIN. And you can see this person has a GRIN mutation that only occurs in 3.2% of the population. And I think there's another GRIN up here. No, there's no one there. But these GRINs will cause the NMDA receptor to be upregulated, and then that will stimulate the PLA2 enzyme to bring it out. Now, this is our most recent research. Dopamine, when it gets caught in the dopamine receptor site, will stimulate PLA2. And you can see this person had 2 homozygous here. And then if you don't break down dopamine by COMT or MAOA, it stimulates this. Now, on the other hand, we have a braking system. The body makes something called DHA. And the DHA will calm down the PLA2. But we can have genetic mutations that we don't take our fish oils and turn them into DHA. And then many people know that when they have inflammation, the doctor will give them prednisone or cortisol.
Mm-hmm.
So your body makes cortisol, but here again, we can have genetic issues that we don't make enough cortisol. And this example is an individual who had severe mast cell activation syndrome. Mm-hmm. So there's a lot that can go wrong here, including back to our M1 and our M2. These prostaglandins will eventually stimulate M1, which then goes in a circle of inflammation. Now, last map that we're going to show you, this is no Lyme, but this is the highlights. This one's designed how environmental factors will impact us. And here we have the M1 and the M2. Here's M1, and in this individual, the NRF2 is weak. The mTOR is too strong. It stimulates those same players that we talked about. It stimulates the iNOS. It makes the peroxynitrite. And that stimulates the mast cells. Again, this was a person with mast cell activation syndrome. Mm-hmm. And as we spoke about, it spins around in a circle and makes more superoxide, and around we go in a circle. And then lastly, I'm sure you've seen people that you gave them progesterone and they felt better, and some people felt worse.
Yeah.
Yeah. So what happens is progesterone can go one of two ways. It can actually make more aldosterone that makes more inflammation, or it can make the cortisol that breaks down the excess inflammation. It's controlled by this enzyme called CYP17A1. And you can see this individual had a mutation that occurs in 1% of the population.
Hmm.
Yeah. And then we need the POR enzyme to handle over NADPH. This one occurs in 1% of the population. So in this example here, the progesterone was more likely going to make more inflammation rather than be anti-inflammatory, feeding the
Mhm.
mast cell activation syndrome.
Hmm.
Yeah. So again, this does not diagnose disease. It's not a treatment for disease, but it's looking at where there's missing function
Mhm.
and then where the function can be, keyword, compensated for.
Well, and knowing your genetics can help identify too, like what supplements are going to work best for you. Which supplements do you need lifelong because these pathways are not open? And which ones, a lot of people just load on supplements. I see it every day. People come in with 50, 60 supplements that they're taking and they have no idea what's working, what's not, what's making them feel worse. But having a genetic test done like this can help us identify like what is it that you actually need to get your body back to where it should be instead of guessing and just spending thousands of dollars a month on supplements.
Yeah, I mean, I see people, it's like, how in the world do you swallow that much?
Yeah, I
And
agree.
most
I don't know how they do it.
and most of them are not doing well anyway.
Yeah. Yeah.
So, I mean, you start looking at it, oh, you're taking this multiple vitamin with methylfolate in it. Then you're taking this B complex with methylfolate in it. And it's like, okay, no wonder you're so anxious. Okay.
Right.
And then one of my favorite pet peeves is that there's this trend if you have an inflamed gut to take these powders with glutamine.
Mm-hmm.
And that might be okay. Okay. But I see it backfiring more than helping.
Mm-hmm.
So the theory behind it is glutamine helps the growth of new cells, and that's going to help your gut replenish its cells. But glutamine turns into glutamate. And if you've got this thing revved up, that glutamine is going to make more glutamate. That may then further stimulate NLRP3 and
Mm-hmm.
make more inflammation.
Yeah.
So, yeah, so people are, oh, my gut's inflamed, and I was taking this glutamine powder, and it's like, now I'm not saying that's not helpful under some conditions.
Mm-hmm.
Under some conditions, it is.
Right.
But if you've got this upregulated and you throw more glutamine in, you're just going to do that.
Mm-hmm.
Then the other one that happens sometimes is people learn about N-acetylcysteine.
Mm-hmm.
And oh, N-acetylcysteine makes glutathione.
Mm-hmm.
Yeah,
And it's great for long haul.
right. And it is.
It
However,
is.
here's the however. The cysteine comes in using this enzyme right here called SLC17A11.
Mm-hmm.
Excess glutamate will shut it down.
Hmm.
And then the cysteine, rather than doing these good things, can actually be inflammatory. Oh, and you know what? I was amiss not talking about G6PD. So you'll often see this in people with Native American background, African background, Sicilian background. So the G6PD mutation is one of the most common mutations in the world.
Hmm.
And what happens is G6PD is critical to make your NADPH. Now, it's interesting. It's believed that this started in Africa, and I don't honestly know the mechanism. I couldn't explain it. But this G6PD mutation protected you from malaria.
Hmm.
I don't know how. But right now, having that G6PD mutation limits your body's ability to make NADPH. And one of the trends right now is methylene blue.
Yeah.
And methylene blue is fine under some conditions because what it does, let me see if I can find it real quickly. Methylene blue donates an electron at the end of the electron transport chain. So you think, okay, I'm going to take methylene blue and I'm going to feel better. I'm going to get more energy. I mean, it makes sense because that's what it does. Okay.
Hmm.
But if you've got G6PD, it's actually contraindicated and can make
It
things
does. Can
worse.
make things worse.
Yeah. So here's the electron transport chain. And here's where those electrons bebop on down through here. Well, methylene blue just dumps an electron down here, so you make more energy. But I don't know, I don't think we fully understand the mechanism, but what I'm wondering is, and this is just a hypothesis, not a statement, if these electrons then don't fly off and make superoxide.
Mm,
Don't know. That
yeah.
damages the red blood cells. Then if you don't have G6PD, it's contraindicated.
Hmm.
So I'm not against methylene blue, but you should know if you got G6PD first,
Yeah.
particularly if you think there's any Native American, African, Sicilian background.
Hmm.
Yeah.
And there's a lot of people just buying methylene blue over the counter at a lot of different supplement companies and starting to take it and having issues for sure.
Oh, yeah. Yeah. Now, what's interesting is, for a lot of men, erectile function is a serious issue. Not only erectile function, but from a
Hmm.
standpoint of blood flow. So what's fascinating here is that methylene blue has an interesting effect. The We get something called GTP that goes through this enzyme and does vasodilation.
Hmm.
So if anybody's familiar with Viagra and Cialis, they inhibit the PD5 enzyme that inhibits this. So you take Viagra or Cialis, it inhibits the guy who inhibits this, blood flow is improved. However, methylene blue inhibits just like PDE5.
Hmm.
So methylene blue potentially, let's use that word, could impact the vasodilation.
Sure.
So yeah, we got to be real careful that we just don't take things willy-nilly and too
Yeah.
much of them. So I think those are the highlights that I wanted to
Right.
show.
So
Now,
this is your software system that you've created to look at genetics. Tell us a
oh
little
yeah,
bit.
yeah, yeah. What I did about 14 years ago, I started using 23andMe and I made a spreadsheet
Hmm.
and I loaded it up
Yes.
and put the information in. And then doctors learned about it and they said, well, we want to do this too. So for a period of time, I was upgrading the spreadsheet, sending it to them. It's like, well, this isn't working too well.
Hmm.
So I created my own software. And then many years ago, 23andMe went to their version 5 and they dumped about
Yeah.
40% of the enzymes that we were looking at.
Hmm.
So it's like, yeah, okay. Do I want to do this or not? So I bit the bullet and I worked with Thermo Fisher to develop my own chip.
Hmm.
So we have our own genetic test. And this software has now taken me close to 13 years and $7.5 million in programming costs.
Wow.
Yeah. And then I mean this humbly, but the feedback I'm getting from practitioners is like, there's nothing that has this level of detail.
Hmm.
Yeah. Yeah.
Yeah, I mean, just looking at this from a person that looks at genetics, there's nothing like this that I've seen that goes into this kind of detail that can find all the different spots like your software is doing right now.
Yeah, it's not for the faint of
Amazing.
heart.
Hmm.
Uh, to use this, you honestly have to study a little bit.
Yeah.
Now, we're working on that. One of the feedbacks we get from doctors is like, Bob, this is incredible. This is the future.
Hmm.
I know this could be helpful, but I don't have the time or willingness to study.
Hmm.
So what we're doing now, and this is what's really becoming difficult, but we're making what we call executive reports.
Hmm.
So we're trying to make it as easy as possible.
Yeah.
So we're making executive reports that if you don't want to look at a map, because some people love the maps,
Hmm.
other people glaze over. They're like, what?
It's too much. It's a
It,
little overwhelming for them for sure.
yeah. So this is going to take a little while to load, but we make executive reports that, oh, this is the executive pyramid report. I got the wrong one. Okay. So no wonder it was taking so long. So we'll, oh, shoot, try to get out of here. But anyway, it's making an executive report that walks you through each step and tells you where there's weakness. So yeah, here we go. So we're going to look at the reports. We're going to look at the executive reports. There we go. So, for example, here we have one on sirtuins and NAD. This
Hmm.
one shouldn't take too long. So, what it does, it tells you what sirtuins do. Then it shows you a little diagram, and then it'll tell you what SIRT2 does. And it says, in this person, there's no genetic variance. It actually tells you that. SIRT3, it points out the ones you have. And then it summarizes, and then it gives you potential interventions. So this is only for the doctors, but
Hmm.
it'll tell you there's a product called SIRT cofactors that we made. And then we give the doctor the ability to actually make a custom uh, formula if they want through personalized nutrients, if they want to make it custom. The advantage to that is when people get several supplements, you can have crossover the ingredients, you get too much.
Right.
So for the doctor who says, you know what, I don't want to look at maps. Oh my God, that's too complicated.
Hmm.
We have these reports. Now we're in the early stages of this. We're just in the discussion. But we also, what we want to do is we want to use AI that we program ourselves, not chat GTP or anything else.
Right.
We want
Hmm.
to get our own proprietary AI that we program with our own language, so it doesn't pull from anywhere else.
Hmm.
And it's going to give you a report that says, this one might be the most important one. That's probably a year out in development.
Yeah,
And
that's
that's probably going
exciting.
to cost a couple $100,000
Yeah.
at best. But that's
Yeah.
the level of granularity because we need to make it simpler. I mean, I live and breathe this stuff. This is all I do.
Yeah.
I do it 9 to 11 hours a day, 6 days a week. So I know this stuff like the back of my hand.
Hmm.
But for the doctor who doesn't do it, they look at this and they glaze over.
Hmm. Absolutely.
Yeah.
So if somebody's listening to us and they want to use your software, how do they do that? How do they get in touch with you?
Sure. I'm going to put up a slide here.
Okay.
Let me find the slide. Here we go. So it's called functional genomic analysis, functionalgenomicanalysis.com. And just go there and you can sign up for a free trial. And then we have two support people that help you with it. And
Excellent.
then for somebody who wants to learn the basics, we also have a certification course that
Mhm.
walks you through. And then this is our research. This is the software, functional genomic analysis, cloud-based software. This is the name of the test, your genomic resource. And then we have our own, we worked with personalized nutrients to come up with supplements that support each of the functions. So,
Mhm.
but if somebody wants to, now this, please, if you're just a consumer, don't try to sign up because it's for doctors only. We're going to ask you
Yeah.
about your degree. And so functionalgenomicanalysis.com. And then they can sign up, talk to these folks.
Mhm.
Although I have a busy schedule, if somebody'd like to try to work with me, I still have some openings now and again. Uh,
Awesome.
our clinic's name is Tree of Life Health, tolhealth.com. Fill out the intake form. We'll get you to get to the genetic test. Then we'll do a Zoom call just like this and look at your genome and find where the weak spots are. So
So if you're a consumer listening, you want to become a client of Dr. Bob's. If you're a practitioner, though, you want to go to functionalgenomicsanalysis.com and sign up for an account.
right.
Yeah. Wonderful.
And we do webinars every other Thursday evening where we geek out.
That's awesome. I love it.
Yeah. Are you on our webinars at all?
I am not. I wasn't aware of
Well,
that.
I'll have to get you the link. So
Yeah, please do. That would be great. I
yeah,
would love
last
to.
night we geeked out on the arachidonic acid pathway.
Okay.
Thursdays 8 to 9:30 p.m. Eastern Standard Time.
Excellent.
Yeah.
Well, thank you so much for sharing all this information with us. And it was absolutely wonderful. And
Good.
you can tell it is truly your passion.
It's a lot of fun. But when you get to my age, you start thinking about your legacy. What did you do for the world?
Hmm.
And so it's so heartwarming when I hear back from an autistic parent that, hey, my kid's doing better. They're not banging their head against the wall.
Yeah.
Or somebody says, I can get out of bed now for the first time.
Hmm.
Can't think of anything more fun.
Yeah. Isn't that the truth? Because then you can really make a difference with people.
Yeah. So we're hoping to be pioneers in this. And so we've made quite the mess with all these environmental factors.
Yeah, we sure
And
have.
I often tell folks who have autistic kids, I'll say, if your kid been born 70 years ago, they might be rambunctious,
Hmm.
but that'd be about it.
Yeah. Yeah, and unfortunately, because of all the things we've done to our environment, it's different now.
Hmm.
Yeah. Well,
Yeah, we
thank you.
really messed up. Well, it's been a pleasure. This was a lot of
Thank
fun.
you. Thank you. You too. I appreciate your time.
Okay, have a great rest of the day.
Thank you. You too. Thank you, Dr. Bob, for sharing how functional genomics is changing the way we understand health and disease. If you're listening and you've spent years chasing symptoms without relief, maybe this is the missing lens. Your genes may not be your enemy, they might be your roadmap. To learn more, visit Dr. Bob's work at Tree of Life and explore genetic research and Nutrigenetic Research Institute. And as always, remember, wellness isn't about feeling better. It's about uncovering the truth within your body so you can thrive. Until next time, I'm Dr. Deb reminding you to take care of your body, mind, spirit. Be well, and I'll see you on the next episode. Welcome to Let's Talk Wellness Now, where we bring expert insights to you. Please note that the views and information shared by our guests are their own and do not necessarily reflect those of Let's Talk Wellness Now, its management, or our partners. Each affiliate, sponsor, and partner is an independent entity with its own perspectives. Today's content is provided for informational and educational purposes only and should not be considered specific advice, whether financial, medical, or legal. While we strive to present accurate and useful information, we cannot guarantee its completeness or relevance to your unique circumstances. We encourage you to consult a qualified professional to address your individual needs. Your use of information from this broadcast is entirely at your own risk. By continuing to listen, you agree to indemnify and hold Let's Talk Wellness Now and its associates harmless from any claims or damages arising from the use of this content. We may update this disclaimer at any time, and changes will take effect immediately upon posting or broadcast. Thank you for tuning in. We hope you find this episode both insightful and thought-provoking. Listener discretion is advised.